Welcome to this combined concept and examples video for bearings with Trig, where we go over what it is and how we do it. Let's get started. So for this topic, we'll need to use sine and cosine rule. So if you want to revise this, go back and watch my example and concept video on sine and cosine rule. But let's do a quick recap. So the sine rule is used when the question involves two angle and side pairs. So maybe we've got one angle side pair and we've got one component of the other one. It's being used this rule to find the missing component. And we use cosine rule when the question involves three sides and an angle. So we might have all three sides and we're looking for any of the angles, or we might have two sides and an included angle, and we might be looking for the side opposite that angle. Again, for a recap, just the link will be in the description to the other videos. So let's start off with what bearings actually is. So a bearing is a way to define a direction from a point as long as you know where the north line is. So maybe you've got a compass on you can define a direction. And the direction is defined with the angle clockwise from the north line, so here it might be roughly 50 degrees. But when we write bearings in terms of 3 digits so that it's not ambiguous. So for example here the bearing would be 050. And if you had an angle of like 2 or 3 degrees, you just put 002 or 003. So here we can say that the bearing from A to B is 50 degrees. And if you look at another point, a point C, we can say the bearing from A to C is all the way around from the north clockwise to that point, so it would be 260 degrees roughly here. We need to quickly talk about all the points of the compass, because this comes up frequently in questions. And the key point is that all directions are perpendicular to each other, i.e. there's 90 degrees between each two directions. So if something's due east of the north of a point, we say that its bearing's 90. If it's due south, it has a bearing of 180. And so on. If it's west, it has a bearing of 270 degrees. And this will come up quite frequently in questions, so it's good to get practice and get comfortable with them. On the note of getting practice, let's have a look at some past paper questions. So, fortunately everything we need in this question is on the diagram, but let's highlight a few key things. It wants us to find the bearing from the yacht to the trawler. So here the yacht is represented by Y, and the trawler is represented by the T. So we're looking for the bearing from the yacht to the trawler. So we're looking for, the bearing of the yacht from the trawler. So we're looking to start at the north line of the trawler and go all the way around until we get to the line between the trailer and the yacht, the trawler and the yacht. Okay, so first thing we note is we've got this angle here already. It's 240 degrees. So that means that if we find this angle inside the triangle, then we'll have the full bearing. So we can notice straight away that we've got three sides and we're looking for an angle, so we need to use the cosine rule. And don't worry, you'll get given this in your paper. It'll be at the start. I'm trying it down here so we know what we're doing. So let's label the angle we want as the capital A in the equation, and the angle opposite, the side opposite the angle has to be the lowercase a, remember. And we can label the other two sides B and C. It doesn't matter which way down they ones go. And we'll put these values into the equation on the right. So we'll replace A with X, B with 5.6, C with 10.3, and our lowercase a with 7.2. Just taking the values from the picture and put it into our equation. And there'll be a calculator question, so you pop this on your calculator. Cos x will come out to be 0.7421, and the reason I've kept lots of decimal places is because we're not done yet, because we don't want cos x, we want x, so we take the inverse cos of that answer we got above. Pop that in your calculator, and it'll come out to be 42 degrees. So now that we've got that internal angle x, we should realise that the bearing is just the 240 plus the angle we found. So we'll write down that the bearing is the 42 degrees that we just found, plus the external angle of 240, and that gives us a full bearing of 282 degrees. And that's us. Let's look at another one. So in this question, first thing I notice, let's highlight the key information first. So what's the distance between Dunbridge and Fairtown, which is just D and F here. So we're looking for this side, and I'll just label it as X. So whenever I start bearings questions, I don't worry too much about where I'm trying to go. If it gives me angles, I'll try and work out the internal angles of the triangle first before doing anything else, because that'll usually come in the question, either in the form of the sine or cosine rule. So we notice first of all that at this angle 126, it looks like the side to the north line to the horizontal line is right angle, and we can't assume that. So how do we know? Well, let's go back and read the question, and we notice that it says that Dunbridge is west of Elsford, which means that this line here is going to be a right angle, because E is east of Dunbridge if Dunbridge is west of Ellsworth. And that also means that this side over here is also going to be right angled because both north lines are going to be perpendicular to that horizontal line. Okay, so what information can we use here? Well, that means we can find the internal angle here, because if the north line all the way down to that line is 126, to find the angle inside the triangle, we can just take the 126 and take the right angle off of it, and it leaves us with finding out the angle inside the triangle as being 36 degrees. And we can do a similar thing around on the other side of the triangle, the other bearing we're given, because we're given the right angle and the external angle. So if you remember, the whole way down from north all the way back to north is going to be 360 degrees. We can find the angle inside the triangle by just taking the angles we've got away from 360. So we'll take 360, and we'll take away the outside angle of 230. We'll take away the 90 degrees we've got, and that leaves us with just the angle that we want inside the triangle, which will be 40 degrees. This is the part of the question that a lot of students don't like, because it's not obvious where you need to start. But for all the questions, if there's information given outside the triangles, like angles and bearings, I always use that to try and find the angles inside the triangle. Now, it may look like we've used all the information we can to fill out information inside the triangle, but remember, now that we've got two angles, you can always find a third, and I'd recommend always finding a third angle just in case you need to use it. You don't always have to use it, but frequently you do, so you may as well find it, because it's quite an easy sum. So we can find this angle by noting that all the angles of the triangle have to add up to 180, so we can just take away the two angles 36 and 40 from 180 to find the last angle, 104, and you should be quite familiar with that process. So now we've got all three angles, and remember we're looking for x, so the first thing we can notice is that because we're looking for x, I'm going to sketch out this triangle first, just so it's a little bit less messy. So we've got the three internal angles, we found all them, and we've also got this side here, it's 15, and we're looking for this side x, and what we can notice is that we can form one angle and side pair from the x and the angle opposite, and we've got another angle side pair. We've got the 15 across from the 104 degrees, and because we've got two angle side pairs, it's going to be the sine rule. So I'll write out the sine rule in terms of putting the sides on top, just because it's easier if you write it that way. And let's label on our little diagram here what each side is going to be. So the thing we want is going to be x, so we'll just call that small a, and obviously the angle opposite has to be uppercase a if that's the case. And we'll label the other one B, lowercase and uppercase b. And let's plug this into our equation. So replacing the letters with the things we've labelled them as. And to get x on its own, we just have to multiply both sides by sine 40. So that essentially means bringing sine 40 up to the other side. And if you pop that on your calculator, x comes out to be 9.94 kilometres. And the reason we know that it's in kilometres is because this side here, 15, is given in kilometres, so that means that the other side is also going to be in kilometres. We need to remember to check the question to make sure that we've got the right units. So let's move on to the last example. Okay, so let's take a second to read the question. It looks like not all the information from the question is on the actual diagram, so we'll add that in a second. But let's just note what the first part is asking us first. It's asking us to calculate the size of the angle CDH, which is just this angle here, the angle at D. Okay, so the first bit of information it gives us is that D is on a bearing of 40 degrees from C, and if I extend the north line, that means that this angle here is 40, because a bearing is just the clockwise angle from north. Okay, next thing to note is that it says here that C is due east of H, so that means that this guy here is right angle. It looked like one already, but we can double check that it's just by looking at the information. Okay, so immediately just from these two things, we can get why the angle's inside the triangle, which is really how you want to start these questions. You want to try and always get an angle inside. Because this big angle here is just that right angle plus 40 degrees, so this angle here is just 90 plus 40, which gives us 130 for this guy here. And I'm going to draw the triangle out again, just to so it's less cluttered, and I'll mark on what we've got so far. So we've got on these two sides here, just from the question, and we found that this angle is 130, and we're looking for this angle x here. And what you can notice already is we've got one angle side pair here, we've got another one here, so again we can use sine rule to find the angle that we want. So I'll write out sine rule, but this time I'll write the angles on top of the fractions. This is perfectly loud, you can flip both sides of the equation. Go and check my sine and cosine video to see a little bit more explanation. But I put these on top just because it means rearranging the equations a bit easier. And the angle we want is capital A, the one opposite is lowercase a, and the other two are b and b. And if we sub these into the equation, replacing the letters with the numbers, then we get this guy here. And in order to get sine x on its own, we just times both sides by 50, so we basically bring 50 up to the other side. And if you pop everything on the right hand side of that equation on your calculator, it'll come out to be 0.485. Again, I'm keeping some decimal places here because we don't want just sine x, we want x. So if we find x, we take the inverse sine of that, so we just got. And you put that on your calculator, it'll come out to be 29 degrees. Okay, so that's done part A. But part B is asking us to find the bearing on which Yacht must sail to return to the harbour. So once it's bearing 2H, and where are we right now? Well, it says at the start of the question that it ends at point D. So we want the bearing from D to H. So I'm going to wipe this away so we can get a bit more clear picture of what's going on. And we want the bearing from D to H. So then we go all the way around from north clockwise round to the dotted line there. And this is the angle we want. We'll fill in what we found out from part A. We found this 29 degrees. Right, and now what we want to do is to get this big external angle all the way around from the north to the dotted line. We'll need to find the outside angles as well. So let's write back in some of the information that we had. So we knew that this angle here was 40, and this is all information that we've got. So when I'm trying to find other angles, there's a few different rules you can use. If you use like Z angles or J angles, but what I like to do is I like to just stretch all the lines out further. So I'm going to take this line, I'm going to project it further along, and what you'll notice now is that this angle here is 40 degrees because it's the exact same angle as this, because both the angles are formed by taking a north line and then taking the same line from C to D. So because the sides are the same for both angles, the angle between them is going to be the same. So that means we know that because this is 40, the angle up here is 40. And now what we've also got a straight line here, so this guy's just 180. Which means the total bearing, all the way from the north line right way around to the dotted line, is going to be this 40 plus this 180 plus this 29. So let's write that down. Let's add them all together. And that'll give us the full bearing of 249 degrees, which we're looking for. If you're not a fan of this method of extending lines beyond, you can also identify what's called a Z angle. So let's take this little part of the triangle at the side and have a look at it again. So this angle here we know is 40, this one's 29, and we can identify this Z angle here in blue, and that means this guy's 40. And then we can do the exact same steps before, and just add all the angles together and it gets the exact same answer. The key step in this one is just this blue line here identifies a Z angle. It's essentially the same method. It's just I can never remember the Z angles and all the J angles and all the X angles, all the different ways it linked. But yeah, you can use this method. That's fine too. Whatever you prefer, just give it some practice. Right, so we're gonna round out this video with why we care about bearings in this topic. So bearings themselves are useful because you only need to know north to define a direction. So if you have something like a compass on you, you can write down what direction you're going in, and tell, if you're on a radio with somebody else, you can tell them I'm bearing at this direction, and all you need to know is north. You don't need to know anything else really to define a direction. This topic involves working with angles and geometry, and working angles and geometry appears across STEM in general. A lot of the proofs and derivations we do in physics just rely on the geometry and the angles in the problem. I know other areas STEM will always use angles geometry as well, and just something that comes up a lot when you try to model real life situations, and sometimes not real life situations too. And lastly, this is basically an application of Sine and Cosine Rule, so just practice applying skills and knowledge to new contexts, i.e. bearings here. It's just a useful skill in general, taking what you know and apply it to the new situation. So this brings us to the end of the video, and indeed the end of the series. I really hope you enjoyed and found this useful, and good luck with any exams you might be sitting.